Every night, when we look up at the sky, we see stars scattered like diamonds across a dark canvas. They seem peaceful, silent, and eternal. But the truth is far more dramatic. Stars are not still. They are born. They grow. They burn with unimaginable power, and in the end, they die in spectacular and sometimes violent ways. Our sun is a star. It gives light, warmth, and life to Earth. Without it, our planet would be a frozen wasteland drifting in darkness. But like all stars, the sun was once a cloud of gas and dust floating in space, and one day it will cease to shine. The same is true for every star in the universe. This is the story of the secret lives of stars, a story that begins in cold, silent clouds, rises to blazing nuclear fire, and ends in glorious explosions or quiet collapse. It is a story that explains where light comes from, where planets come from, and even where we come from. Because every element in our bodies, from the calcium in our bones to the iron in our blood, was forged inside stars. In this documentary, we will follow a star's life from birth to death. We will explore where stars are born, how they shine, why some die peacefully, and why others explode with more power than billions of suns combined. We will uncover the true nature of red giants, white dwarfs, neutron stars, and black holes. This is not just a story about light. It is a story about time, creation, destruction, and the very fabric of the universe. Deep in the darkest regions of our galaxy, far from city lights and human eyes, enormous clouds of gas and dust drift in silence. These are called stellar nurseries. They look still from the outside, but inside, they are full of motion. Gravity slowly pulls the gas together, forming clumps. These clumps grow heavier, colder, and denser over thousands of years. At first, there is nothing that looks like a star, just darkness and swirling dust. But as gravity keeps pulling, the center of the cloud becomes hotter. Invisible forces compress it from all sides. When the core reaches millions of degrees, something extraordinary happens. The atoms of hydrogen, the most common element in the universe, are forced together. They merge. They become helium. This process is called nuclear fusion, and it is the moment a star is born. The newborn star glows for the first time. It is called a protostar. It is still wrapped in a cocoon of dust, but its light begins to break through. Around it, the leftover gas begins to flatten into a spinning disk. This disk is the birthplace of planets, moons, and asteroids. Not every cloud becomes a star. Some clumps are too small or too cold. Others form groups of stars instead of just one. Our sun was likely born in a family of stars inside a giant cloud, surrounded by siblings that have long since drifted away. From a quiet cloud in space to a glowing ball of fire, the birth of a star is a battle between gravity pulling inward and radiation pushing outward. If nuclear fusion continues, the star survives. If it stops, the star collapses before its life can truly begin. Every star you see in the night sky was born this way. So was our sun. And as we continue this journey, we will see what happens after that first spark of light. Once a star is born, it enters the longest and most stable part of its life. This stage is called the main sequence. During this time, a star shines steadily by turning hydrogen into helium deep in its core. This process releases a tremendous amount of energy in the form of light and heat. That energy travels outward from the core, through the layers of the star, and finally into space. It is this light that reaches Earth and warms our planet. The sun is in this stage right now. It has been shining for about 4.5 billion years, and will continue to shine for about 5 billion more. In this time, it remains stable because two powerful forces are perfectly balanced. Gravity pulls everything toward the center. At the same time, the energy from nuclear fusion pushes outward. As long as these two forces remain in balance, the star lives in peace. Not all stars are the same. Some are massive giants, much larger and hotter than the sun. They burn brighter, but they also burn faster. They use up their fuel in just a few million years. Others are small and dim, called red dwarfs. They burn slowly and gently. Some red dwarfs may shine for trillions of years, far longer than the universe has even existed so far. The color of a star tells us about its temperature. Blue stars are the hottest. White and yellow stars like the sun are medium in temperature. Red stars are cooler, but they are often the most common in the universe. Stars also change over time. As they burn hydrogen in their cores, helium builds up. The core slowly grows heavier and hotter. But when the hydrogen begins to run out, the balance that kept the star stable starts to break. What happens next depends on the size of the star. A star like the sun will begin to expand into a red giant. A star much larger than the sun will face a more explosive fate. But in every case, the calm middle age of a star eventually comes to an end. The peaceful light of stars that we see in the sky is not permanent. It is part of a much larger journey, one that leads toward transformation, collapse, or even cosmic destruction. Every star, no matter how bright or powerful, will eventually run out of fuel. When that happens, the true nature of the star is revealed. Its peaceful glow gives way to transformation. Some stars fade quietly. Others die in violent explosions that can outshine entire galaxies. Let us begin with stars like our sun. For billions of years, the sun has been fusing hydrogen into helium. But once most of the hydrogen in its core is gone, the balance between gravity and energy begins to break. The core shrinks and becomes hotter, while the outer layers expand. The sun will swell to hundreds of times its current size and become a red giant. In this stage, the sun will engulf the inner planets. Mercury and Venus will be destroyed. Earth may be swallowed or scorched beyond recognition. The sky, once blue, will turn red as the giant sun fills the horizon. As the core continues to collapse, it grows so hot that helium begins to fuse into carbon and oxygen. But this process cannot last forever. Once the helium is gone, the core can no longer produce enough energy to fight gravity. The outer layers drift away into space, forming a delicate cloud of glowing gas called a planetary nebula. At the center, the core remains. It becomes a small, dense object called a white dwarf. A white dwarf is about the size of Earth but contains nearly as much mass as the sun. It no longer shines through fusion. It glows faintly with leftover heat, then slowly cools over trillions of years. This is the final fate of stars like the sun. But for stars much larger than the sun, the story is very different and far more dramatic. Massive stars burn through their fuel quickly. When their hydrogen and helium are gone, their cores fuse heavier elements such as carbon, oxygen, and iron. But iron cannot produce energy through fusion. When the core becomes mostly iron, it collapses under its own weight in less than a second. This collapse triggers a spectacular explosion called a supernova. In that explosion, the star tears itself apart. It releases more energy in a few seconds than the sun will release in its entire lifetime. The explosion sends heavy elements such as gold, silver, and uranium into space. These elements later become part of new stars, planets, and even living beings. What remains after a supernova depends on the mass of the original star. If the core left behind is small enough, it becomes a neutron star. If it is too massive, gravity crushes it further into a black hole, a place where even light cannot escape. From glowing birth clouds to catastrophic deaths, stars live lives full of power, beauty, and tragedy. And in their deaths, they give life to new worlds. When a star dies, it does not simply disappear. What remains can be even more mysterious and fascinating than the star itself. These remnants are the final forms of stellar evolution. They are white dwarfs, neutron stars, and black holes. Each one tells a different story about the life that came before. A white dwarf is the final stage of a star like our sun. It no longer produces energy through fusion. Instead, it glows with the last of its heat. A white dwarf is incredibly dense. Imagine a star with the mass of the sun compressed into the size of Earth. A single teaspoon of white dwarf material would weigh as much as a car. Over trillions of years, white dwarfs cool down and fade into dark, cold objects called black dwarfs. None exist yet, because the universe is not old enough for them to fully cool. Neutron stars are born from the explosive deaths of massive stars in supernovae. When the core collapses, it crushes atoms. Electrons and protons fuse into neutrons. The result is a city-sized sphere packed with more mass than the sun. A neutron star is so dense that a teaspoon of its material would weigh billions of tons on Earth. Some neutron stars spin rapidly and release beams of radiation from their magnetic poles. As they rotate, these beams sweep across space like a lighthouse. When they point toward Earth, we see them as pulses of light. These stars are called pulsars. Others have magnetic fields millions of times stronger than anything on Earth. These are called magnetars, and they can release bursts of energy powerful enough to affect planets light years away. But the most mysterious remnants of all are black holes. If a collapsing star is extremely massive, even neutron pressure cannot stop gravity. The core collapses into a single point of infinite density. This creates a region of space where gravity is so strong that not even light can escape. This boundary is called the event horizon. Black holes do not suck everything in. They simply bend space and time around them. If the sun were replaced by a black hole of the same mass, Earth would continue to orbit it as usual, although the planet would be cold and lifeless without sunlight. Some black holes are formed from stars. Others are much larger and sit at the centers of galaxies. These are called supermassive black holes. Our galaxy, the Milky Way, contains one at its heart. It is called Sagittarius A. It has the mass of millions of suns. These remnants remind us that stars, even in death, shape the universe. White dwarfs, neutron stars, and black holes are not just endings. They are also new beginnings. They create the ingredients for planets, life, and the birth of new stars. Every star is a factory. Deep within its core, the intense heat and pressure turn simple elements into complex ones. The universe began with hydrogen and helium, the two lightest elements. Everything else, from carbon to iron to gold, was created inside stars. In stars like our sun, hydrogen fuses into helium. As the star grows older and hotter, helium fuses into carbon, oxygen, and other light elements. But only in massive stars does fusion continue far enough to create heavier elements such as neon, magnesium, and silicon. Eventually, iron is formed at the very center. Iron is the limit. Fusion can no longer produce energy. At this moment, the star collapses and explodes as a supernova. In that explosion, temperatures rise to unimaginable levels. In those final seconds, elements heavier than iron are created. Gold, silver, uranium, and many rare elements are born in the chaos. After the explosion, these elements are scattered across space. They drift in clouds of gas and dust. Over time, gravity pulls these clouds together again. New stars form. New planets form around them. And on some of those planets, under the right conditions, life begins. This means that everything around us, every mountain, every drop of water, every living creature, is made from the remains of stars. The carbon in our bodies was formed in the furnace of an ancient star. The iron in our blood was created in a supernova billions of years ago. The gold in a wedding ring was born in the death of a star. Stars do not just create light, they create life. Without them, the universe would be dark, cold, and empty. No planets, no oceans, no humans. So when we look at the night sky, we are not just looking at distant suns. We are looking at the source of our existence. Stars are not everlasting. One by one, they will all use up their fuel. The bright young universe we see today will not remain the same forever. In time, the cosmos will grow darker and colder. But this journey will unfold across unimaginable stretches of time. The first stars formed more than 13 billion years ago. Today, new stars are still being born in vast clouds of gas. But those gas clouds are being used up. In the distant future, far beyond human existence, the birth of new stars will slow and eventually stop. The universe will enter its quiet age. Small stars called red dwarfs will be the last to burn. They live for trillions of years. Long after the sun and all the stars we see today are gone, red dwarfs will continue to shine faintly across the darkness. But they too will run out of fuel. One day, even the last red dwarf will fade. White dwarfs will cool and become invisible. Neutron stars will grow cold and silent. Black holes will drift through space, swallowing whatever gets too close. Far into the future, black holes themselves may slowly evaporate, releasing their energy back into the universe. Eventually, only particles of light and matter will remain, scattered across an enormous, dark, and nearly empty universe. This possible ending is called the heat death of the universe. It is not an explosion. It is a slow fading. A universe with no stars, no planets, and no warmth. A universe where everything has ended in silence. But this is only one theory. Scientists still explore other possibilities. Some wonder if the universe might one day stop expanding and begin to collapse. Others suggest that new universes might form beyond our own, each with its own stars, galaxies, and possibilities. Whatever the final answer, one truth remains. Stars are temporary. Galaxies are temporary. Even the universe has a story with a beginning and an end. Yet within that story, life appeared. Stars lived, died, and created the elements that made us. And for a small moment, on a small planet, beings like us looked up at the stars and asked where we came from and where we are going. Long before telescopes, spacecraft, or science, human beings looked up at the night sky in wonder. Ancient civilizations studied the stars to guide their journeys across seas and deserts. Farmers watched the stars to know when to plant and harvest. For thousands of years, stars were calendars, compasses, and symbols of hope. In every culture, stars became part of stories, myths, and beliefs. Some saw them as the souls of ancestors. Others believed they were the eyes of gods watching over the world. The Milky Way was seen as a river of light, a path to the afterlife, a trail of heroes through the heavens. Long before science explained what stars truly are, humanity felt their power. Today, we know that stars are not magical fires in the sky. We know they are massive spheres of burning gas powered by nuclear fusion. But knowing this has not taken away their mystery. In many ways, it has made them even more beautiful. Because now we understand that they are not just above us. They are within us. Every atom of carbon in our cells, every atom of oxygen in our lungs, every atom of iron in our blood was formed inside stars that lived and died long before Earth existed. We are made of the universe itself. We are not separate from the stars. We are part of their story. Stars also remind us of our smallness and greatness at the same time. They remind us that Earth is just one planet in one solar system, in one galaxy, among billions. Yet they also remind us that life, consciousness, and curiosity arose in this small place. Humans are the way the universe is beginning to understand itself. When we look at the stars, we see our past, our origins, and our possible future. One day, we may travel beyond Earth to live around other stars. We may build new homes on other worlds. The starlight that once guided ancient travelers may guide us across the galaxy. This is why stars matter. Not only because they give light or create life, but because they connect us to our history, to our future, and to the universe itself. From silent clouds of dust to blazing giants of fire, from peaceful white dwarfs to unstoppable black holes, the lives of stars shape everything we see and everything we are. Stars are not just distant lights in the night sky. They are creators, destroyers, and storytellers of the universe. They are born in darkness. They spend their lives shining against the void, and they die in beauty or in violence. In their final moments, they give back to the universe. They release the elements that form new stars, new planets, and new life. Without their deaths, there would be no oceans, no trees, and no people asking questions about the universe. We are living in a universe built by stars. Their light is ancient. Some of the stars we see tonight no longer exist, but their light continues on, crossing the vastness of space to reach our eyes. To look at the stars is to look back in time. One day, our own sun will reach its end. It will grow into a red giant and then fade into a white dwarf. But the elements it leaves behind, the carbon, oxygen, and iron, will return to the galaxy and become part of future worlds. This is the secret life of stars, a cycle of creation and destruction that continues across billions of years. A reminder that nothing in the universe truly lasts, yet nothing is ever truly lost. If you enjoyed this journey into the heart of the cosmos, into the story of how stars live and die, consider staying with us for more. There are more mysteries to uncover, more worlds to explore, and more questions that only the universe can answer. Subscribe to the channel, leave a comment, and join this growing community of explorers. Together, we will continue to travel beyond the familiar, into the hidden universe that surrounds us.